Hi, thanks for tuning in to Lesson 0, Session 1, Multiplying by Two-Digit Numbers. Lesson 0 is designed to go at the very beginning of the 5th grade math curriculum to help students review and brush up their skills from 4th grade. The learning target in Lesson 0, Session 1 is I can multiply a whole number of up to 4 digits by a 1-digit whole number and multiply two two-digit numbers. Try it. Make sense of the problem. We're going to use the try, discuss, connect strategy. So I am going to read it to you first, and then I'm going to pause to give you a chance to read it to yourself. Folding chairs are set up in a school auditorium for a play. There are 16 rows of chairs. Each row has 28 chairs. How many folding chairs are set up for the play? Now I'm going to pause to give you a chance to read the problem to yourself. If you're still reading, go ahead and press pause so you can finish and then press play again. So let's go through this one more time, a third time, and this time we're going to be looking at what is the problem about. So I'm going to get my pen out and I'm going to underline what our problem is about. So let's read through it again. Folding chairs are set up in a school auditorium for a play. There are 16 rows of chairs. Each row has 28 chairs. How many folding chairs are set up for the play? So this problem is about folding chairs are set up in the school auditorium for a play. What are we trying to find out? I'm going to change my pen color. Let's do purple for this one. Folding chairs are set up in the school auditorium for a play. There are 16 rows of chairs. Each row has 28 chairs. How many folding chairs are set up for the play? So what we are trying to find out is how many folding chairs are set up for the play. I'm trying to draw those lines straight. Finally, what information is important? So I'm going to change my color one more time to green. And the important information I see is what is left here in the middle row. There are 16 rows of chairs, so I'm going to circle 16 rows. Each row has 28 chairs. So I'm going to circle each row has 28 chairs. Now, every time you do a math problem, whether you're doing it together with the teacher in class or watching the video here with me or when you're doing it on your own, this is the process that I would like you to go through. This is going to make it a lot easier to make sure you're actually answering the question and answering what they are actually trying to find out and using the information that is actually important. So now at this point, what I would like you to do is pause the video so you can solve this on your own. You can use whatever strategy or method you think would be best to find the answer. And then we're going to go over that in just a little bit. All right, so by now you should have this problem on the previous slide solved, and if you don't, make sure you pause the video so you can go back and solve that problem before we move on. This is the discuss it part of our routine. This is where we share your thinking with a partner. Now, I know if you're at home doing this problem by yourself, you may not have somebody around that you can discuss with. You can talk to yourself, you can talk to a stuffed animal, an imaginary friend sitting next to you named Steve. Maybe you can talk to a family member. Whatever you're doing to discuss this, I just want you to be able to talk through your thinking here. Here's some discussion starters. Use these to start sharing your thinking. I'm not sure how to find the answer because the strategy I used to find the answer was. Do you agree with me? Why or why not? And why did you choose that strategy? So pause so you can have those discussions, and then we're going to go through the problem. Okay, now it's time for the discuss it portion of our routine. This is where we compare class strategies. We have our problem here that folding chairs are set up in a school auditorium for a play. There are 16 rows of chairs. Each row has 28 chairs. How many folding chairs are set up for the play? If you got the answer of 448 chairs are set up for the play, that is awesome. Great job. You got it correct. If you did not get that answer, that's okay, because we're going to be working through this problem and you're going to get many more chances to practice this skill. So here are some strategies that you can use to solve this problem. One way you could have solved this is by using an area model to multiply two-digit numbers. So we were multiplying 28 by 16. And so what we can do is break these numbers up according to their place values. So 28 is the same as 20 plus 8. And we can see that up here on the top. We have 20 plus 8. There's our 28. And 16 is the same as 10 plus 6. And so we can see there's our 16 on the side. Now we call this an area model because in order to find the area of a rectangle shape like this, what you do is you multiply the length times the width. So it's basically just making a picture of this multiplication problem where we're multiplying 28 by 16 and breaking them apart according to their place values. So then we have these smaller rectangles that are made, kind of like a grid. If we multiply 20 times 10, we have 200. And then 8 times 10, here we have 80. And then 6 times 20, we have 120. And then 6 times 8 is 48. And then if we add the area of each of these rectangles together, we have 200 plus 80 plus 120 plus 48. And that would give us 448. Another method that you could have used is multiplying two-digit numbers using partial products. So here we have our multiplication problem, 28 times 16. So we're multiplying 6 times 8 first, which is 48. That's 6 ones times 8 ones. And then we have 6 ones times 2 tens, because the 2 is in the tens place. So 6 times 20 is 120. And then we have 10, because the 1 is in the tens place. 10 times 8 is 80. And 10 times 20 is 200. And when we add together all of these partial products, then we still get the same answer of 448. Now, one other method that you could have used is just regular old multiplication, where you're still basically doing the partial products, but a lot of it gets done in your head. So that would look like this. Now, is any of these strategies better than any other? No. Is it bad if you use one strategy over another strategy? Of course not. What I want to see you doing in this lesson is trying out different strategies to come up with the solution. Let's connect it. Why is the area model divided into 4 sections? So think about your answer and write it down in your workbook, and then press play so that you can see what I say. The area model is divided into 4 sections because we have 4 digits in our numbers. 28 is made of a 2 and an 8, so we have 20 plus 8, and 16 is a 10 and a 6. So combined we have 4 sections. How do the 4 steps in the multiplication using partial products and model it relate to the four sections in the area model and picture it. And I'm actually going to go back and let you see that. So here's the area model. So we have 200, 80, 120, and 48. And now if we look at the partial products, we have the exact same numbers that we saw in the area model. So basically what the area model was doing was helping us to find the partial products. Number 3, what is the sum of the partial products and also the product of 28 and 16? The product is 448. Number 4, would the product change of 20 plus 8 on the top of the area model were changed to 10 plus 10 plus 8? Explain. So go ahead and pause to find your explanation and then press play when you're ready. So I am actually going to try this out. I'm going to make this area model. So there's the area model. I tried to make my lines as straight as I could. So let's see if it comes to the same product. So we multiply 10 times 10 to get 100. And then 10 times 10 is 100. And then 10 times 8 is 80. Okay, now 6 times 10 is 60. And 6 times 10 is another 60. And 6 times 8 is 48. All right, so I'm going to write all of these partial products, all these areas, over to the side. All right, there we go. There's all of the partial products from inside the boxes. And one thing that I'm noticing is these duplicates here. 100 plus 100 is 200, which was one of my numbers on the other one. If we look back, yep, there's 200. And 60 plus 60 is 120. And then 80, we can keep 80 just the same because there's only one of them. And we're going to keep 48 because there's only one of those. So if we look at our numbers here, 280, 120, and 48, those are still the exact same numbers that we had that we looked at before. So no, the product would not change if we change the area model to 10 plus 10 plus 8. Basically, we're still using the same numbers. 10 plus 10 plus 8 is still 28. We just broke it down a little bit further. Number 5. How could you estimate to check the reasonableness of your answer to 28 times 16 by multiplying with easier numbers? So go ahead and pause to come up with your answer. And then when you're satisfied with your answer, go ahead and press play again. So what I would do, estimate tells me to round my numbers and then solve. So to make it kind of easier on myself, I'm going to do my work up here so I have a little bit more room. I would round 28 to the nearest 10, which is 30. And I would round 16 to the nearest 10, which is 20. Almost wrote 16 there. And I would multiply those. So I have just that 0 I'm going to drop down. And 2 times 0 is 0. And 2 times 3 is 6. So the number that I got here is 600, which isn't exactly close to 450, but it's kind of in the ballpark. I would say that's pretty reasonable. Now, if I wanted to get a little bit closer, maybe I want to use more compatible numbers. So if I round 28 to 30, And maybe for 16, I'll just keep it 16. That's going to make it a little bit easier for me. So I can drop my 0, and 3 times 6 is 18, and I carry the 1, and I get 480, which is a lot closer. So yes, I would say that my answer is reasonable. Number 6, reflect. Look back at your try it, strategies by classmates, and picture it and model it. Which models or strategies do you like best for multiplying a 2-digit number by a 2-digit number? Explain. So if you need to look back in the video and look at some of the different strategies that we used, or look back in your book, figure out which one do you like the best, which one works the best for you, and why do you like that one the best. Apply it. Apply your thinking to a new problem. Number 7. Complete the area model below. Then add the partial products to find the product of 27 and 21 and show your work. So this is going to be an independent practice. I want you to pause the video until this problem is finished. And then when you have the problem finished in your workbook, please press play to check your work. Okay, hopefully you have this done in your workbook so we can check. We're going to multiply the sides of each square here. So we have 20 times 20, which equals 400. And then we have 20 times 7, which equals 140. 1 times 20, see it's this row in that column, is 20. And then 1 in the 1 row and the 7 column is 7. So let's add all these together. So when we add all of these together, we should get 567. Thank you for joining me for Lesson 0, Sessions 1 and 2. I will see you next time for Lesson 0, Session 3. Have a wonderful day.